So LeetCode 1769, minimum number of operations to move all balls to each box. So you're given a binary string that represents your boxes, and the character is 1 if the box is full and 0 if it is empty. So 1 if it has a ball inside of it and 0 if it doesn't have a ball. And you need to output an array where every element is how many steps would it take to move all of the other balls to your current position. So for example, here it's 1 because we just need to move this ball, the second ball, to the first box. And here it's the same thing. You just need to move the first ball to the second box. But here it is 3 because you need 1 step to bring this ball over, and then 2 steps to bring this ball over because it takes 1 step to bring it here and then another step to bring it here. So it's 2 steps. Okay. So the key to solving this problem is keeping track of how many balls you have to your left and to your right. Because once you have, for example, the result for this position, so you know that it takes 1 step to bring all balls here, now you can keep track of how many balls you have to the left and how many you have to the right. And since you're moving to the next position, you're moving to the right, so all of the balls that are to your right are now going to take 1 less step, because you are 1 step closer to all of them, right? And instead, all of the balls that are to your left are taking 1 more step for each one of them because you're getting 1 step farther from them. So yeah, that's all there is to this problem. So we're going to implement that logic. So we start with the counts, how many balls we have to our right, how many balls we have to our left. And then we have our result array, which is going to be what we return at the end. And then we have the steps that are needed for every position in the boxes. And this is going to be what we have to calculate. So what we do first is we calculate how many steps we need to move all of the balls to the first position. And then all of the other positions are going to come by math. So very simply, we check if the current box is equal to 1. And if so, then we need I more steps to get to the 0 position, right? Because if we find a ball at the position 5, then we need 5 steps to bring it to the position 0. Perfect. And now we also have found 1 ball, meaning that we have 1 more ball to our right. Like right now, all of the balls are to our right. Perfect. So now we know how much it takes, how many steps are needed to bring all of the balls to the first position. And notice that if we have a ball in the first position, steps gets incremented by 0. So that's perfect. Okay, and now that we know that, now we know how many steps it takes to move all of the balls to the first box, the box with position 0. Now we can deduce, by that we can calculate how many steps it takes to move all of the balls to the other boxes one by one. So the first thing that we do, we have another loop. And the first thing that we do is we assign to the current position, to the result at the current position, the current amount of steps. And so for example, here we've calculated how many steps it takes to move all of the balls to the position 0. And so we assign that to the result at position 0. And now we check if the current box is a 1. And if so, that means that we have 1 less box to our right, like one less ball to our right, because the ball is right here. So we are going to move it past that. And so it's not longer going to be to our right, and instead it's going to be to our left, right? So we passed this ball. So we need to update the count of how many balls we have to the right and how many balls we have to the left. And now with this counts, we can calculate how many steps it will take for the next position to have all of the balls transferred to that position. And that is just simply we add 1 for every ball to our left, and we remove 1 for every ball to our right. And then we do the same thing again. So we assign to result, check if we need to update the counts, and update the steps needed, and so on and so on and so on. So once again, the steps are incremented by 1 for each ball to your left. And that's because you're moving to the right. So you're getting 1 step farther from every ball that you had to your left. And you're getting 1 step closer to every ball that you had to your right. So you decrement steps by 1 for every ball that you have to your right. And yeah, that's it. I'll submit the code to show that it works. And the time complexity is O of n, because just loop through the boxes array twice. And the space complexity is, again, O of n, because you need an array for the result. So that's it from me today. Thank you for watching, and bye.